Yes, it is permissible to use a 500 kcmil conductor for a 400 amp service. The ampacity of a conductor refers to the maximum current it can carry without exceeding its temperature rating and potentially causing damage or failure. This ampacity is determined by several factors, including the conductor's size, the material it's made from, and its insulation temperature rating. A 500 kcmil copper conductor with an insulation temperature rating of 75 degrees Celsius typically has an ampacity of 380 amps according to the National Electrical Code or NEC. However, the NEC provides flexibility in certain situations. One such provision allows the use of conductors at higher temperature ratings than the marked rating, provided they are installed in a raceway or enclosure also rated for that higher temperature. This means if the terminations and equipment are rated for 90 degrees Celsius, and the 500 kcmil conductor is also rated for 90 degrees Celsius and installed in a 90 degrees Celsius rated raceway, you can utilize the higher ampacity rating of the conductor as per the NEC ampacity tables. Another NEC-sanctioned method for achieving a desired ampacity involves running conductors in parallel. When conductors are run in parallel, the overall ampacity of the circuit is equal to the sum of the individual ampacities of each conductor, as long as certain conditions are met. If you were to consider using 3/3/0 copper conductors in parallel, each conductor would need to have an ampacity sufficient to carry a portion of the 400 amp load. To determine if 3/3/0 conductors can be used, refer to the NEC ampacity tables. For example, if 3/0 copper conductors with 75 degrees Celsius insulation are used, they typically have an ampacity of around 200 amps each. 3 of these in parallel would provide a total ampacity of 600 amps, which is more than sufficient for a 400 amp service. However, there are important considerations when running conductors in parallel. Firstly, all parallel conductors must be of the same length, conductor material, circular mil area, insulation type, and be terminated in the same manner. Secondly, the overcurrent protection device must be sized appropriately to protect the conductors. Thirdly, the conductors must be installed in the same raceway or cable. So, to summarize, for a 400 amp service, you have options. You could use a single 500 kcmil copper conductor, taking into account the temperature rating of the conductor, terminations, and equipment. Alternatively, you could use 3/3/0 copper conductors in parallel, ensuring that all the NEC requirements for parallel conductors are met. Always consult the NEC and local electrical codes for specific requirements in your jurisdiction, and ensure that any electrical work is performed by a qualified and licensed electrician. It is crucial to understand the concepts of ampacity, temperature ratings, and parallel conductors to ensure a safe and code-compliant electrical installation. The goal is to ensure the conductors are protected by proper overcurrent protection. You must follow NEC Table 310.16 for ampacity. Temperature correction and adjustment factors in accordance with NEC 310.15 must be followed. You have to ensure the equipment is rated to take the wire size. The terminals have to be rated for the wire size also. You can use 500 kcmil for a 400 amp service if all the terminations are rated for 75 degrees Celsius. You can use the 75 degrees Celsius ampacity, and the overcurrent protection is 400 amps. In addition, there are other considerations. Firstly, voltage drop. You want to ensure that the voltage drop is not excessive for the length of the run. Secondly, short circuit current rating. You want to make sure the conductors can withstand the available fault current. Thirdly, dirting factors. You must consider the number of current-carrying conductors in a raceway. If there are more than 3 current-carrying conductors, the ampacity of the conductors must be derated according to NEC Table 310.15 cone. Fourthly, ambient temperature correction. If the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductors must be corrected according to NEC Table 310.15. In summary, Using a 500 kcmil conductor or paralleling smaller conductors for a 400 amp service involves careful consideration of ampacity, temperature ratings, NEC guidelines, and other factors to ensure a safe and compliant electrical installation. Always consult with a qualified electrician and adhere to local electrical codes. When you're dealing with electrical installations, the National Electrical Code, or NEC, is your primary guide. It provides detailed requirements for safe wiring practices. One key concept is ampacity, which refers to the maximum current a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC Table 310.16 is a crucial reference point, as it lists the allowable ampacities of insulated conductors rated up to 2000 volts based on the conductor size, insulation type, and ambient temperature. For example, a 500 kcmil copper conductor with a 75 degrees Celsius insulation rating has an ampacity of 380 amps. However, this is just a starting point, as various factors can affect the ampacity you can actually use in a given installation. Temperature is a critical factor. The NEC recognizes that conductors heat up as they carry current, and excessive heat can damage the insulation and pose a fire hazard. Therefore, the NEC specifies maximum operating temperatures for different types of insulation. If the ambient temperature is higher than 30 degrees Celsius, you must apply a correction factor to reduce the allowable ampacity. Similarly, if you have multiple current-carrying conductors bundled together in a raceway or cable, the heat generated by each conductor can raise the overall temperature, requiring a directing of the ampacity. The NEC provides tables to help you determine the appropriate directing factors based on the number of conductors. Another important consideration is the temperature rating of the terminals and equipment to which the conductors are connected. The NEC generally requires that you use the lowest temperature rating of any connected component. For example, if you're using a 500 kcmil conductor with a 90 degrees Celsius insulation rating but the terminals on your breaker are only rated for 75 degrees Celsius, you must use the 75 degrees Celsius ampacity for the conductor. Parallel conductors offer a way to increase the overall ampacity of a circuit. However, the NEC has strict rules for paralleling conductors. All parallel conductors must be of the same length, conductor material, size, insulation type, and be terminated in the same manner. The NEC also requires that you size the overcurrent protection device to protect the conductors, and that you install the conductors in the same raceway or cable. Using 3/3/0 copper conductors in parallel is a common way to achieve a higher ampacity. However, it's important to ensure that each 3/0 conductor is properly sized and protected, and that all the NEC requirements for paralleling conductors are met. Voltage drop is another crucial factor to consider. As current flows through a conductor, there is a voltage drop due to the conductor's resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, you can use larger conductors or shorten the length of the run. Short circuit current rating is another important consideration. Conductors must be able to withstand the high currents that can flow during a short circuit without melting or causing a fire. The short circuit current rating of a conductor depends on its size, material, and insulation type. The NEC requires that you select conductors with a short circuit current rating that is sufficient for the available fault current at the point of installation. Directing factors must be considered. If you have more than 3 current-carrying conductors in a raceway or cable, you must direct the ampacity of the conductors. The NEC provides tables to help you determine the appropriate directing factors based on the number of conductors. Ambient temperature correction is another factor to consider. If the ambient temperature is higher than 30 degrees Celsius, you must correct the ampacity of the conductors. The NEC provides tables to help you determine the appropriate correction factors based on the ambient temperature. In summary, selecting the right conductor size for a 400 amp service requires a careful consideration of ampacity, temperature ratings, NEC guidelines, voltage drop, short circuit current rating, directing factors, and ambient temperature correction. Always consult the NEC and local electrical codes for specific requirements in your jurisdiction, and ensure that any electrical work is performed by a qualified and licensed electrician. Understanding the principles of ampacity and how it relates to conductor size, temperature, and installation conditions is crucial for ensuring a safe and reliable electrical system. The NEC provides a comprehensive framework for electrical installations and is essential to follow its guidelines to protect people and property from electrical hazards. By paying attention to detail and using the NEC as your guide, you can ensure that your electrical installations are safe, efficient, and code compliant. Remember, electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. The information provided here is for educational purposes only and should not be considered a substitute for professional advice.